In this video, we are going to see how we can convert this 5 function from time domain to complex frequency domain known as S domain. And in doing so, we are going to use this formula, which is the general formula for finding the Laplace transform of a function. And starting with function 1, which is f of t is equal to k, which is just a constant, I will have this relationship. So the general integration for exponential of at dt is just exponential of at over a. And applying it to this relationship, I will have this solution. So I just have to apply the limit now. So applying the limit, I will end up with f of s is equal to k over s. So for the second function, f of t is equal to t. So I will have this relationship. In order to solve this integration, I have to apply integration by part. So this is the general formula for integration by part. I will choose my u to be t. Therefore, differentiating it, I will have du dt is equal to 1, which will lead to du is equal to dt. And then I will choose my db to be equal to exponential of minus st dt. So integrating both sides, I will have this relationship, which will end up with this integration, exponential of minus st over minus s. So applying these two lines into my integration by part, I will end up with this relationship, which will give me f of s from here, as you can see. So you can see I have this part which is already integrated, so I have to integrate the second part. So integrating the second part, because I already have minus s here, and integrating exponential of minus st will lead to another minus s, so I will have s squared. Applying the limits, I have to first of all apply the infinity part, then minus, I will apply the 0 limit. So solving further, I will have this, and finally my f of s will just be equal to 1 over x squared. So moving to our third function, which is f of t is equal to exponential of minus at. Applying the formula, I will have this, and then applying the law of indices, my exponential will reduce into this. So I just have to apply the formula I showed you for exponential, integration and exponential, and I will end up with this solution. So I just have to apply the limit here. Applying the limit, it will reduce to this, and then finally my f of s will just be equal to 1 over s plus a. In order to solve my fourth and fifth function, I have to apply Euler's formula, which are given by equation 1 and 2. So adding 1 and 2 and solving a bit further, my cos omega t will just be equal to exponential of I omega t plus exponential of minus I omega t over 2. And applying it into the Laplace transform formula, I will end up with this relationship. So I just have to apply the law of indices, and my exponentials will reduce into two parts. So I have to integrate the two parts, and then doing the integration, I will end up with this. Applying the limits, I will end up with this relationship, and it will reduce into this. So I just have to take the LCM, which is the two functions, and then I will have this denominator and this numerator. So I just have to add the numerator and then multiply the denominator. So doing so, I will end up with this relationship. During the solution of the denominator, I have to keep in mind that I squared is equal to minus 1. So from here, it will reduce into f of s is equal to s over s squared plus omega squared. So for the sine function, I have to do subtraction. So subtracting 2 from 1, my sine omega t will end up into this. For writing my sine omega t relationship, I will end up with this. So substituting it into the general Laplace transform formula, my f of s will just be this. So now I have to also apply the law of indices, which will lead me into two different exponentials. So for each exponential, I will have to apply the limits. I have to integrate it separately and apply the limit. So doing so, I will end up with this solution, and I have to apply the limit for each one. So applying the limit, it will reduce into these exponentials, and then finally I will have this relationship. So you can see the LCM is just s minus I omega and s plus I omega. So applying the LCM, my denominator will be this and my numerator will be this, and solving further, I will have this relationship. So my f of s will just finally be omega over s squared plus omega squared. So if you want to learn how you can easily find this Laplace transform in MATLAB, watch the video on the screen. Please like and subscribe to the channel. Thank you for watching.